Number 13 and 14 are pretty much the same idea, so we're just going to look at one of them. They want us to take an equilibrium constant and calculate delta G and E cell. Before we actually solve the problem, let's do a little predicting. This equilibrium constant is really, really small, so we're not expecting very much in the way of products. It's mostly going to be reactants. And because of that, because it's not very favorable in the forward direction, that means that delta G is going to be, what sign is delta G going to be? I think it's going to be positive because it doesn't proceed very far towards products. And the cell potential, E cell, what kind of voltage are we expecting? Well, it doesn't proceed very far towards products, so I think we're going to get a negative voltage. So by doing this prediction, we can check and see if our answers are right when we actually work the problem. Now for both of these, we're going to need two equations, so I'm going to write them down. And there are the two equations. So we're going to start with K. We are going to notice the temperature for both problems seems to be 298. And remember that when we do R is going to be 8.314 joules per mole Kelvin. So it's in joules, so our answer for delta G is going to come out in joules, and you might want to be wary about that before you plug in an answer. And then the voltage is simple. We now know the joule, or the delta G. We know Faraday's constant. We can find the cell potential if we know N. And you'll notice in this one they didn't give us an equation to balance to figure out what N is, but they did tell us it was a 2-electron redox problem, so I think N is going to be 2. And there we go. We'll get the answer, and the answer will be in volts because a volt is a joule per coulomb, and we already have delta G in joules. When you do the one on number 14, be wary, N has changed, but other than that, it should be pretty straightforward.